Welcome back to the Foundry by Forge College. So in our last explainer on social platforms and user engagement, we spent a lot of time looking at the flashy front-end stuff. All that interactivity, the likes, the shares, those never-ending feeds that basically keep us glued to our screens. But today we're completely flipping the board over. We're going to dive into the massive, hidden data plumbing underneath all those features. We're talking about centralization, data control, and the security trade-offs that absolutely define the Web 2 era. Basically, we're looking at the digital duct tape and the hidden vaults holding up the modern internet.
Let's just unroll the master blueprint real quick and outline exactly how we're going to deconstruct the Web 2 ecosystem today. We'll start with the Web 2 City Hub, look at data custody versus ownership, see how they monetize that master blueprint, check out single points of failure, break down the whole Cambridge Analytica situation, and finally look at rebuilding for the future.
All right, Section 1, the Web 2 City Hub. To really wrap our heads around platform centralization, we're going to imagine a Web 2 platform as this massive, bustling megacity. Honestly, the metaphor lines up perfectly. Just like a physical city hub, a Web 2 platform has a central train station. In our digital city, that's the routing and load balancing infrastructure, making sure all the user traffic flows smoothly so nobody crashes into each other. It's got a marketplace, which is basically your ad exchange and recommendation engine, aggregating goods and deciding what you actually see. And then, absolutely crucially, it has a central registry. That's the massive user database storing all your identity records, your preferences, your behavior logs, the whole shebang. Every single time you scroll, you are essentially taking a walk right through the middle of this city. Now, what's really fascinating about this setup is the incredible trade-off you make. On one hand, you get amazing operational efficiency. Having a central hub is just ridiculously convenient. You get lightning-fast searches, unified single sign-on across a dozen different apps, just a totally seamless experience. But look at the flip side. All that aggregated value creates immense systemic risk. You're dealing with massive correlated risk, a single owner pulling literally all the levers, and common failure modes. It's kind of like taking all the gold in your entire city and dumping it into one giant vault protected by just one set of guards.
And that brings us right into Section 2, data custody versus ownership. This is a vital distinction when we're talking about all the information flowing into that central registry vault.
Okay, let's talk about custody. I'm sure you've clicked I agree on 100 terms of service agreements that proudly proclaim, hey, you own your data. And legally, sure, you might own the copyright to that photo of your avocado toast. But the platform has operational custody. That means they actually store it on their servers, they process it, and they control exactly who gets to see it. Think about it. It really doesn't matter who holds the legal deed to the gold if somebody else is holding the actual keys to the vault and deciding when those doors get to open.
Because they have custody at scale, these platforms control your practical realities. They control the system backups, they enforce the deletion policies. I mean, when you hit that little trash icon, is it actually completely erased or just hidden from your view? They manage all the access logs, they handle the user permissions, and they totally dictate your data export capabilities. Basically, custody dictates what's practically possible, completely overriding any theoretical legal ownership you might have. Moving right along to Section 3, monetizing the master blueprint. So you might be wondering, how exactly does this central custody turn into massive, eye-watering profits? Let's build this out step by step. Step 1, aggregate the data using that central custody we just talked about. Step 2, take that massive pool of behaviors and match advertisers to highly specific user segments. Step 3, run relentless A/B experiments to boost engagement and keep you scrolling forever. And Step 4, sell targeted access to partners. Notice what's missing here? The platform doesn't even need to sell your raw personal data. By simply holding custody, they can monetize the access patterns, the aggregated statistics, and the ability to put a specific ad in front of your specific eyeballs at the exact right microsecond. It's a goldmine. All right, we are now at Section 4, single points of failure. As you progress through the programs at Forge College, you'll see a recurring theme. Wherever you concentrate power, you concentrate risk. A single point of failure is basically a technical or organizational choke point. It's the one load-bearing beam holding up the entire roof. In Web 2, a platform relies on thousands of interconnected microservices. That means if, say, an intern trips over the wrong server cord or just one access key gets compromised, the effects ripple out and the whole city can come grinding to a sudden halt. Let's look at the architectural blueprint of these vulnerabilities. If the authentication service fails, that's the part checking passwords and issuing access tokens, you don't just get a glitchy login screen. Attackers can take over millions of accounts all at once. A breach in the user data store, highly sensitive personal info gets stolen. If the recommendation engine is manipulated, you suffer algorithmic bias. And those third-party integrations? Exposing APIs is basically like handing out master keys to outside contractors. If they get hacked, well, you get hacked. We call that a supply chain compromise. Let's make this super concrete and step through a little accident investigation. Here's the credential breach cascade. Step 1. An attacker sends a fake email and phishes a single, solitary developer's password. Step 2. Using that credential, they access internal dashboards and those master keys we just mentioned. Because everything is highly centralized, Step 3, they can now exfiltrate user records across multiple, entirely different products. Finally, Step 4, they monetize that stolen data on secondary dark markets. A simple tricked employee escalates into a massive, multi-product data meltdown. Wild, right?
Okay, moving to Section 5, Breakdown, Cambridge Analytica. Let's actually examine one of the most famous structural collapses in Web 2 history to see how this plays out in the real world.
Just consider how this sequence played out. Time 1. A third-party app gets consent from a user to take a fun, supposedly harmless little personality quiz. But then, time 2, the platform's APIs granted overly broad access, not just to the quiz taker's data, but to all their friends' metadata too. Time 3, all those signals were vacuumed up and combined with public records. Which leads to time 4, the creation of powerful, highly sensitive voter targeting models without anyone really knowing what was happening. This brilliantly illustrates how a seemingly harmless quiz exploited platform custody and permissive access to siphon off a massive amount of the friend graph. The crazy part? The fundamental issue here wasn't some incredibly complex technical bug or a brilliant hack. It was a business incentive. The drive for quick growth, frictionless integration, and massive data aggregation highly favored easy API access over rigorous security governance. Honestly, the system behaved exactly the way it was incentivized to behave.
Which brings us to our sixth and final section, rebuilding for the future. We've seen all the foundational cracks, so the crucial question is, how do we actually patch them?
Well, Web 2 engineers certainly try to limit the blast radius using some very concrete defensive tactics. They enforce least privilege, so an employee only has access to exactly what they need for their job and absolutely nothing more. They tightened and strictly limit what those APIs can actually see. They segregate and encrypt backups completely separately from the main system. And they implement tamper-evident audit logs, which are basically unerasable digital footprints, so they can see if someone was sneaking around. But here is the harsh, unavoidable reality, and I quote, "Concentration amplifies both value and risk. A single breach in a centralized system yields higher payoff for attackers than faults distributed across independent nodes. As long as the system remains centralized, it is always going to be a massive, highly lucrative target. You can build a taller wall around the city's central vaults, sure, but it is still the biggest, most tempting vault in the world. The incentives for attackers to break in are simply astronomical."
So, I'm going to leave you with this final thought. If the City Hub model is inherently vulnerable by its very design, how do we architect distributed neighborhoods where you actually hold your own keys? A place where custody and ownership are literally the exact same thing. As we prepare for our next explainer on APIs and web services, where we'll look at these permission models up close, I want you to really chew on that question. Thank you so much for joining me today. Be sure to visit forge.college to continue your learning journey and explore the decentralized solutions of Web3. Catch you next time.